In this video, I'm going to show you how to solve a linear system using a data table. And a linear system is just a fancy math term for two people or two things or two relationships that are changing with a constant rate. And in this case, it's two birds. And I want to solve for when they are going to be at the same height. So here's the problem that we're dealing with here. It says an eagle soaring high above spots a pigeon lazily flying below. It's mealtime for the eagle, so it decides to dive down and grab it. The eagle starts 200 feet above the ground and descends or flies down at 12 feet per second. The unsuspecting pigeon was 65 feet above the ground and flies upwards at 3 feet per second. After how many seconds will the eagle grab the pigeon, and what will be their height above the ground at that time? So I'm going to solve this one, in this case, with a data table. So the first thing I need to do is set up my data table. So in this one, I'm going to have three columns, one for time in seconds, another column for the height of the eagle at each of those seconds, and a third column for the height of the pigeon after each of those seconds. And one thing about using this method is I don't know what the answer is going to be yet, so I'm not really sure how many seconds I need to put here in my time column. Maybe it's going to, the eagle will catch the pigeon after only 4 seconds. Maybe it'll be 10. Maybe it's going to be longer than 10. Maybe I'm going to have to extend this even farther beyond 10. We'll just have to wait and find out. So the first thing I need to do is I need to get their starting heights in here. And it's important to make sure when you do that, you're starting with time 0, which normally when we count, we start with 1. But in situations like this where I'm having a starting height, I want to know what is their height at time 0 in the story. Before the story even begins, what are their two heights? And according to the story, the eagle starts at 200 feet, and the pigeon starts at 65 feet above the ground. So those are their heights at the start of the story at time 0, before any time has gone by. Now, where does it go from there? Let's switch over to this one. From here, after every second, I know that the eagle is going to decrease its height by 12 feet. So I'm going to have to subtract 12 for this first row for the eagle, but the pigeon is flying upwards. It's going to add 3 feet to its height. So let's do that. 1 second goes by. The eagle goes from 200 down to 188. The pigeon flies up from 65 up to 68. So now they're a little bit closer to one another. If I keep going like this, eventually this one will decrease and this one will increase until they're at the same height. Let's keep going. 188 minus 12, 68 plus 3, and I get 176 and 71. Let's keep going. After 3 seconds, there are their new times. They're getting closer and closer. 4 seconds. Minus 12 plus 3 gets me here. Minus 12 plus 3 gets me there. I'm getting closer. Minus 12 plus 3, minus 12 plus 3, minus 12 plus 3, and there it is. There it is right there. I know to answer this question now, after how many seconds? Well, it's going to be 9 seconds. 9 seconds is how long it will take. And what will their height be? Their height for both of them will be 92 feet is the height that they will be when the eagle catches the pigeon. So that is how you can use a data table. But let's look at this for a second. What are the pros and cons of using this method? So what do I like about using the data table to solve this one? Pros. There's nothing complicated about it. Nothing complicated. I just set up a table and I just subtracted and added until they matched up. There were no equations to deal with. You didn't have to solve anything. And it only required addition and subtraction. No advanced mathematics of any kind. Elementary school kids could solve this problem using the data table. What don't I like about it? What are the cons? So here's where this method does have some limitations. And the first one is, what if they don't meet until the 52nd row? In this case, I kind of lucked out. I only had to go to row 9. But what if it actually took 52 seconds until they met? I'd get pretty tired of extending this table for 52 rows. That would get old really quick. Another limitation, it requires repeated calculations. And the more time you do that, I know that minus 12 and plus 3, those are not difficult calculations. But if I have to do them over and over and over, the likelihood of me making a silly mistake becomes greater and greater the longer I do that. And if I make one silly mistake in there, my table is going to be off, and then my answer won't quite be right. Another one, what if the answer isn't a whole number? In this case, they met after exactly 9 seconds. But what if they meet at exactly 4.734 seconds? I'm not really going to easily be able to get that one from using a data table. So this works nicely if I'm dealing with whole numbers. But if the answers are decimals, this is going to be a bit of a pain. And finally, what if the two birds are changing speeds with inconvenient decimals? So here I was just going minus 12 plus 3, but what if it was minus 12.375? And what if this was plus 3.129? That starts to get to be kind of a pain. So I like the data table method for easy situations, easy numbers, no decimals. It's very clear, it's very easy, but it does have some limitations. So I'm going to actually make another video that shows you a different way to solve this one using equations. So it is going to require some equations, but it's going to make these cons much easier to deal with. So if you want to see another way to solve the same problem with equations, check out that video. And I hope you found this helpful.